Hello everyone, welcome back to my channel. Let me introduce myself. My name is Jefferson Vijaya from Secondary 2 of Anderson School. Today I'll be bringing to you a presentation about particle theory. But before that, don't forget to like and subscribe in that button below. Enjoy the video.
Small particles in our life make up an object called the state of matter. There are three states of matter, which are solid, liquid, and gas. The examples of solids are ice cubes, tables, rocks, pencils, and many more. An example of a liquid is water, and there are many other liquids like oil and many more. And the examples of gas are the clouds above us and the air that we breathe around us. Every state of matter is made up of tiny particles called molecules. The particle theory states that every molecules are constantly moving. Now, molecules are held together by a strong attractive pull called the intermolecular force. Now, every state of matter has a different intermolecular force, which is what differentiates them from one another. Now, firstly, we're gonna talk about solid molecules. Solid molecules are closely packed and held together by a strong intermolecular force. They have a regular pattern which makes a regular shape. Solid molecules have a fixed shape and volume. This is why solids can flow into different containers. Solids move by vibrating and spinning around its position. Moving on to liquid molecules. Liquid molecules are slightly close with each other. They have spaces between them. The intermolecular force in liquid is not as strong as solids. The molecules are arranged in an irregular pattern. Liquids don't have a fixed shape, but it has a fixed volume. Liquid molecules move around the empty spaces of each molecules. Now, moving on to the last state of matter, gas. Now, gas particles is a little bit different. Gas molecules have a wide space between them due to almost no intermolecular force. Gas molecules tend to fill empty spaces between them. This is why gas doesn't have a fixed shape and volume. Gas molecules move in random directions at very high speeds. Now, to summarize all of these, I am making a few key ingredients. Number one, every matter is made up of molecules that are constantly moving. Two, molecules are held together by an intermolecular force. Three, solid molecules have the strongest intermolecular force. Liquid has a weaker force, and gas molecules almost has no intermolecular force. Now, let's move on. Moving on to changes in state. Every state of matter can change state into another state of matter. For instance, solid to liquid and liquid to solid. But there are many more. There are six types of changes in state, which are melting, freezing, boiling, evaporation, condensation, and sublimation. If we supply thermal energy to an object, it changes state from solid to liquid and liquid to gas. What this means is we have solid molecules here. If we supply thermal energy here, then the intermolecular force between them will decrease because the molecules get more active. When the molecules get more active, then the solid separates to become a liquid, which is this change of state from solid to liquid. But otherwise, when we remove thermal energy from an object, the intermolecular force increases because the objects now become more passive. They move less than when we supply thermal energy. A way to remove thermal energy is to cool down the object. This is what causes water to freeze when exposed to a certain low temperature. Now I am going to show to you guys a simple observation of change of state. For this observation, I am going to use a block of ice. Now let us observe what happens to this ice. after we've seen the observation, we'll discuss together what happened to the ice. Firstly, I'm gonna draw the ice. Now, for example, this is the ice. Inside the ice, we have the solid molecules of the ice. Now, when we leave the ice exposed to the temperature, the ice absorbs thermal energy. Now, after the ice absorbs the energy from the surrounding, then the ice will start to melt. Why? Remember, more energy means more movement, so the molecules inside the ice are moving more actively, which makes them slowly moving away from each other. Now, after they move away from each other, they will try to fill the empty spaces around them, which makes them molecules moving, and slowly the ice melts into a puddle of water. Now, this is just a simple observation. Now, we can conclude here. Molecules, when absorbing thermal energy, will move more actively, which results changes of state from solid to liquid and liquid to gas. This example shows solid to liquid. Tiga, empat. Balik dulu laptopnya guys. Guys. Oke, satu, dua, tiga. Related to energy within molecules, there are two certain temperatures where an object boils or freezes. These are called boiling points and freezing points. These are the points or certain temperatures when an object boils or freezes. Different substances have different boiling and freezing points. For example, we'll take a simple example of water. Now, water has a boiling point of 100 degrees Celsius, while the freezing point for water is 0 degrees Celsius. Now, melting and condensation happens when it reaches the boiling and freezing point. The way to differentiate them is to look at the temperature and situation. For example, if the water is at 0 degrees Celsius but the temperature is rising, then we can call it as melting. But when the water is at 100 degrees Celsius but the temperature is dropping, then we can call it as condensation. Now we're going to talk about the last change of state that we're going to discuss today, which are boiling and evaporation. Now, both of these may look similar, but they have a few differences. The similarities between them is that both are the process where liquid change into gas, while the difference are a lot. Now, the first difference is that boiling can happen when it reaches a boiling point, like mentioned before, which is 100 degrees Celsius, while evaporation can happen at any temperature. Another difference is that evaporation is a passive process, while boiling requires us to supply thermal energy to the object. The example is boiling noodles. When we boil the noodle, we need to supply thermal energy to the noodle in order to get to boil. Another difference is that evaporation draws energy from its surrounding, which is why evaporation doesn't produce any bubbles. Now, these are the differences and the similarities between boiling and evaporation. You can see that there are clear differences between both, but they are both similar in the process. Now, before we end today's topic, I'm going to talk about one last discussion, which are particle theories. I'm going to show to you the most famous characters in the world that have made particle theories. And the first particle theory was made by a Greek philosopher named by Democritus. He stated that all objects are made up of small particles called atoms. Atoms come from the word atomos in Greek, which means indivisible. He stated that atoms cannot be divided into small pieces since they are already small enough. Another Greek philosopher called Aristotle stated otherwise, that atoms can be divided into smaller and smaller and smaller pieces to almost an infinite number. Now, both of these theories look very convincing. Now, who do you think was right after all? And to prove this theory, in the early 19th century, John Dalton made an experiment and came up with a few statements that proved to us all that Democritus' theory was correct, which were: number one, matters are composed of atoms that cannot be destroyed or divided. Number two, atoms of the same element have the same mass and properties. This means that when you break down a rock into molecules, then the atoms will have the same mass and properties. So, for example, this is X kilogram, the other atoms will also have X kilogram. Number three, atoms can be combined to form a compound. And the last statement, chemical reactions occur to the arrangement of atoms. So, for example, melting happens because of the rearrangement of the solid molecules that turn into liquid molecules. So, for those who voted Democritus' theory was right, congratulations. Okay, the video ends here. Thank you guys for your attention. If you found this video beneficial, then you can subscribe to our channel and like this video. And don't forget to share this video. Also write down in the comment what you think of my video so you can make better content in the next video. Goodbye.